The journey through this framework reveals a radical departure from mainstream, peer-reviewed physics, synthesizing a self-published alternative model designed to rewrite the foundations set by Newton and Einstein. By challenging the core tenets of modern cosmology, the theory recasts the universe not as a flexible, relativistic space-time continuum, but as a mechanically driven spatial expanse. Summary of key paradigms. Absolute time. Time is stripped of its relativistic flexibility. It does not dilate, warp, or slow down. It is a universal, uniform tick rate where temporal variations are merely instrumental errors akin to a broken clock. The spatial expanse. Space is not an empty passive backdrop or a curved fabric, but a tangible, continuously generated medium born from an expanding spherical origin, the Hubble universe balloon. The mechanics of force. Through the popcorn universe and the primeval pressure-space gradient theory, cosmic motion, orbits, and spatial structure are driven not by gravitational attraction or warped spacetime, but by an active, idle space field exerting a continuous repulsive push force. Ultimately, this body of work represents a distinct conceptual ecosystem, an independent paradigm that replaces abstract mathematical dimensions with mechanical, pressure-driven dynamics across the cosmic expanse.
Science is full of ideas that can make you stop and think. Sometimes these ideas seem to challenge everything we know. You might come across a statement that sounds incredibly bold, perhaps even a bit strange. One such claim is this: the square root of the speed of light is equal to twice the speed of light. It is a very direct statement. It takes a fundamental constant of the universe, the speed of light, and proposes a simple mathematical relationship. On the surface, it has the ring of a profound secret, a hidden symmetry in nature. But does it hold up to scrutiny? When we face a claim like this, our first instinct as scientists, and indeed as curious people, should be to check it. We should not just accept it because it sounds interesting. We should not dismiss it because it sounds wrong. We should do the maths. The beauty of physics is that many of its grandest ideas can be explored with simple arithmetic. This is one of those moments. First, we need the number itself. The speed of light in a vacuum, c, is a universal constant. Its exact value is 2,999,792,458 meters per second. It is an astonishingly fast speed. A beam of light could circle the Earth more than 7 times in a single second. For our calculation, we can use this precise value. The claim states that the square root of this number should be equal to 2 times this number. Let us calculate both sides of that proposed equation. The square root of c equals 2 times c, and see if they match. It is a simple test, but it will be very revealing. Let's calculate the first part. The square root of c. We need to find the square root of 299,792,458. When you put this into a calculator, you get a result that is approximately 17,314.51. So according to the claim, this number, around 17,000, should be equal to the other side of the equation. Already we might feel a bit of skepticism. The square root of a very large number is a much smaller number. This is a general rule of arithmetic. Now for the second part of the claim, twice the speed of light, or 2 times c, this is a much more straightforward calculation. We simply take the value of c and multiply it by 2. The result is 599,584,916. This is a huge number, close to 600 million. It represents a speed that is, as you would expect, double the speed of light. It is a purely hypothetical speed in our current understanding of physics. Now we have the 2 numbers we need. The moment of truth has arrived. We compare the 2 results. On one side, we have the square root of c, which is about 17,314. On the other side, we have 2 times c, which is about 599 through 584, 916. It is immediately and profoundly obvious that these two numbers are not the same. They are not even in the same ballpark. One is a 5-digit number and the other is a 9-digit number. Therefore, as a statement of simple numerical fact, the claim that the square root of c equals 2 times c is false. The numbers simply do not match up. It is a mathematical impossibility. Beyond the glaring numerical error, there is a second, more subtle reason why the equation C2c cannot be correct. This reason is fundamental to all of physics. It is the problem of units. In science, numbers are almost always attached to units. They tell us what we are measuring. For example, we do not just say the distance is 10. We say it is 10 meters. We say it is 10 kilometers. Its units are meters per second, written as ms. This tells us it is a measure of distance traveled over a period of time. When we perform mathematical operations on physical quantities, we must also perform them on their units. Let us look at the right side first. 2 times c. Here we are just multiplying the speed of light by a pure number, 2. The units do not change. So 2 times c still has units of meters per second. It represents a speed just like c does. This is perfectly fine. If you double your speed in a car, you are still measuring your speed in miles per hour. You are still measuring your speed in kilometers per hour. The unit of measurement remains the same. Now consider the left side, the square root of c. When we take the square root of the number, we must also take the square root of its units. The unit of c is meters per second, so the unit of SQRTC would be the square root of meters per second. This gives us a very strange unit. Meters to the 1/2 per second to the 1/2. This is not a unit of speed. This is not a unit of acceleration. It is a type of quantity with no obvious everyday meaning. It is a different kind of thing entirely. This is the core of the problem. The equation c sure 2c claims two fundamentally different kinds of quantities are equal. One side has units of meters to the 1/2 per second to the 1/2. The other has units of meters per second. It is like saying an area in square meters equals a length in meters. You cannot compare them. It is an apples and oranges comparison. In physics, an equation must be dimensionally consistent. The units on both sides must match. Because they do not, the claim is invalid for this second, very important reason. So the original claim is false, both numerically and in its use of units. Does that mean we should just throw the idea away? Not necessarily. Sometimes a wrong idea can be the seed of a very interesting right idea. Perhaps the person who came up with the claim was not thinking literally. Perhaps they were reaching for a new kind of relationship, a symbolic one. Let us try to be charitable and see if we can build something valid from the ruins of the original statement. We can keep the structure of the equation, but change what it is acting upon. Instead of taking the square root of the number c, what if the square root operation acts on a different physical quantity? Let us imagine there is a new field in the universe. We can call it the quanta field. This is just a name for now, a placeholder for a new concept. A field in physics is something that has a value at every point in space and time. The temperature in a room is a simple example of a field. We are proposing a new hypothetical field, Q. This Q is not the speed of light, it is its own thing. Now we need to choose the properties of this new quantity, Q, very carefully. The main problem with the original claim was the units. The square root of a speed gave us nonsensical units. So Let's define our new quantity Q in a way that fixes this. Let's postulate that Q has units of meters per second squared, or ms squared. This might seem a bit abstract, but it is a perfectly valid type of unit in physics. For example, certain measures of energy or intensity can have units like this. By defining Q in this way, we have set the stage for a new corrected equation. If Q has units of meters per second squared, then the square root of meters per second squared is simply meters per second. Suddenly, the units work out perfectly. The square root of our new quantity, root Q, has the units of a speed, meters per second. Now we have something that we can compare to the speed of light, c, or to twice the speed of light, 2c. We have rescued the mathematical structure of the idea by inventing a new quantity for it to act on. Now that we have our new quantity Q, we can formulate a clear and consistent postulate. We can call it the quanta superluminal postulate. Let there be a new physical quantity, Q, called the quanta field intensity. We define Q so its square root represents a propagation velocity, which we will call v. We then postulate that this velocity v is equal to twice the speed of light. Writing this as a single clean equation, we get v equals root Q equals 2c. This equation is now mathematically and dimensionally correct. The symbol v stands for a velocity with units of meters per second. The symbol Q represents our new field quantity. For the equation to work, Q must be equal to 2c squared. This means Q equals 4c squared. Since c has units of meters per second, c squared has units of meters per second squared, which matches our requirement for Q. Finally, c is the good old speed of light, a constant. Every symbol is clearly defined. The units on both sides of the equation v equals 2c are meters per second. The equation balances perfectly. This is a huge improvement over the original claim, moving from a confusing and incorrect statement to a precise and workable postulate. Having a clean equation is a great start, but what could it actually mean for physics? What is this velocity v that is supposedly twice the speed of light? And what is the field Q? A postulate is only useful if it can connect to some aspect of reality, even a hypothetical one. One interpretation is that Q represents a property of the vacuum of space itself. In our standard understanding, the vacuum has a baseline state, and in that state the speed limit is c. Nothing can go faster. But what if the vacuum can be excited into a different state? Many theories in modern physics, like string theory, suggest the vacuum is much more complex than just empty space. It might have hidden properties that can be activated at very high energies. Our field Q could represent the energy density of such an excited vacuum. In this view, in our normal low-energy world, Q is zero, and the postulate does nothing. But in an extreme environment, perhaps near a black hole, or in the first moments of the Big Bang, Q could become very large, allowing for a new mode of propagation, v, that is faster than light. This idea of a faster than light or superluminal propagation must be handled with extreme care. One reason c is considered a universal speed limit is to protect the principle of causality, the idea that a cause must always happen before its effect. If you could send a signal faster than light, you could, in theory, send a message back in time, creating all sorts of logical paradoxes. Any theory that includes a velocity v greater than c must also provide a mechanism to explain why causality is not violated. Our simple postulate does not do this, but it provides a framework where such questions can be asked. In conclusion, the simple statement that the square root of c equals 2c is demonstrably false. It fails a simple numerical check. It fails the fundamental requirement for consistent units. However, the spirit of the claim can be transformed into a legitimate scientific postulate. By defining a new field, Q, we can write a consistent equation, V SQR TQ, Tritium 2C. This turns a mathematical myth into a potential piece of physics. To make it a full theory, one would need to specify the rules for Q and propose experiments to detect it. This is the way science works. It refines raw ideas, tests them, and builds clear, careful models of our wonderful universe. Let us keep questioning boldly and calculating carefully. Imagine if space itself could give you a fast lane. Imagine if space itself could give you a fast lane. Not warp drives or wormholes, just a proposed way the vacuum might let energy slip through a kind of tunneling corridor. I'm calling this a quantum space field hypothesis. And to keep it clear, I'll label everything as a proposal, not proven physics. First, a definition I can test intellectually. Quantum propulsion definition, C2 equals 2C. C2 is the proposed quantum superluminal propulsion state, and 2C is, well, twice the speed of light. This is not an accepted equation in physics. It's a placeholder to talk about a threshold. Now I need a propulsion parameter to aim for. Proposed propulsion parameter, ET equals 34,096,000 QPU. QPU stands for quantum propulsion units, an invented unit in this framework to keep numbers honest with dimensions. ET is the proposed energy thrust level associated with establishing a quantum space field tunneling path through the vacuum. In plain English, if I could pump the system to ET and QPU, maybe the corridor forms. You'll notice I'm anchoring the idea to a speed label, 2C equals 34,596,000, framed here as an energy thrust magnitude traveling through space. Again, not a measured constant, just a proposed mapping, so the theory has knobs to turn. Let's push the math a bit. If I treat C as 17 times 298,000 in the same internal scaling, then 2C squared equals 2 times 17 times 298,000 squared. That's 2 times 299,000, 20, 804,000, which gives 598,000, 41, 608,000, 1,000. In scientific notation, 5.984416 times 10 to the 20. Within this theory, that number could serve as a benchmark excitation. The quantum space field excitation level needed to flip into the C2 state. Why even consider vacuum tunneling? Because vacuum energy is already one of physics' biggest mysteries. The vacuum catastrophe happens when you try to compute how much energy the vacuum should have. Theory overshoots observation by about 120 orders of magnitude. That's not a rounding error, it's the worst prediction in physics. To feel how wild those scales are, take this toy expression, 2 times the speed squared, then scale by 10 to the 120. Using a familiar speed unit, say 186,000, 2 times 186,000 squared times 10 to the 120 equals 6.9192 times 10 to the 130. Add an extra factor of 186,000, treating 2C with C equal to 186,000, and it blows up to about 1.287 times 10 to the 136. That's the kind of gulf the vacuum catastrophe throws at us. So here's the pitch. Define C2 as a proposed state, define ET in QPU as the target thrust, and explore whether a quantum vacuum tunneling corridor is even mathematically self-consistent. It's not confirmation, it's a sandbox. If nothing else, it forces better questions about energy, units, and what the vacuum really is. And sometimes better questions are the fastest way forward.
In the fabric of space, light energy and graviton particles exist in delicate equilibrium. When relativistic mass collides with this field at near light speed, the particles reset and reorganize, creating a graviton void that deflects light and clears a pathway. A clean pathway for starships to traverse the cosmos.